Yes. All right, so we are on 3C.10 part 1 and part 2 today. We're going to start off with part 1. The beginning part is going to be like just a lot of explaining to you guys what we're leading into, and then we will do some examples, okay? So let's dive on in. All right, here we go. So, looking at these two examples, so equation 1, we have sine x equals 1/2. We have equation 2, and it says sine to the negative 1 of 1/2 equals x. What are these two equations asking? So equation 1 is asking us what? Where is sine equal to 1/2, correct? What is equation number 2 asking? What's that word? Inverse. So this is asking when is sine of x equal to 1/2. This one has no restrictions. Part 1. Part 1.
I see part 1 and part 2. Yeah. The part 2, part 1. Oh, never mind, sorry.
Okay, so this one has no restrictions. However, because this is an inverse function, there are restrictions, right? And the restrictions for this one is that your value, your x, has to be between negative pi over 2 and positive pi over 2, meaning that it's only in quadrant 1 and in quadrant 2. Okay, so do we see the difference in these two equations? So if I just have sine x equals 1/2, and then I have the inverse sine of 1/2 equals x, that's what the difference is. One is no restrictions, one has restrictions. Make sense? Okay. So when we look at our unit circle from 0 to 2 pi, if I'm looking for sine theta with a positive 1/2, that's going to put me in quadrant 1 and in quadrant 2, right? So that means that it's going to be at pi over 6 or pi over 6 or 5 pi over 6. Agree? Because that's when y is a positive 1/2. However, if we're looking for the inverse, the only one that would work would be in quadrant number 1. So the only one that would work is pi over 6. Okay. Does that make sense? Okay. So again, depending on how the equation initially looks, you're going to either have restrictions or no restrictions. No restrictions if it's just a trig equation. Okay. A trig equation that you're solving for the angle. There's no restrictions. If it's a trig inverse equation, there's going to be a restriction. Because remember when we define the function for trig inverses, they have restrictions. They have limitations.
I remember that.
And only can be in quadrant 1 or quadrant 4. Exactly. Okay? And your x value can only be defined between negative pi over 2 and positive pi over 2. Got it? All right. So we see the difference in the two types. And again, please, thank you for rolling with how tiny the screen is for the sake of still being able to make last video. Yes, for the second part. For the first part, it's pi over 6 and 5 pi over 6, right? For the second one, it is just pi over 6 because of the restrictions. All right, so finding general solutions to trigonometric functions. Since trig functions are periodic, we can have infinitely many solutions. Does that make sense? Because you're going around the circle multiple times, and you can go around the circles multiple times in a clockwise motion or in a counterclockwise motion, right? So there's infinitely many solutions that exist. So that's why you have to pay attention to your domain that's given to you. So since here, for equation 1, we were only analyzing it from 0 to 2 pi. Because we were only analyzing it from 0 to 2 pi, our only answers would be pi over 6 and 5 pi over 6. But if I didn't have that restriction of 0 to 2 pi, then my answer would be pi over 6 plus 2 pi. Because I can keep going around the circle multiple times until I get back to pi over 6. Does that make sense? So there's infinite solutions. So this would be your infinite solution. Okay? This can be simplified to this, 13 pi over 6, right? Well, this is another solution. I need a k. Okay, so if we wanted infinite solutions, then we would take that value. So this is just one more circle around. And then so we would have our x would equal pi over 6 plus 2 pi times k, where k is an integer.
What is that?
That means that k can be 1, 2, 3, 4, 5, or -1, -2, -3. But k is a integer.
It just means it can't be a decimal.
It can't be a decimal because it has to be a full rotation, right?
Yes.
And integers are full rotations.
So it's 2 pi times k.
It's 2 pi times k. And then your other one would come from 5 pi. So just one rotation would put me at 17 pi over 6. But if I have infinitely many, x would equal 5 pi over 6 plus 2 pi times k. And again, k can be an integer. That's what this z means. It means integer. If you remember from Algebra 1 when y'all define your real number system.
Can you tell us what the difference is between these two?
Huh?
Can you tell us what is there a difference between? No.
I don't know how to answer it. So you mean between the two answers or between?
The two answers.
So between the two answers, because you had two solutions. So there's two stopping points in your unit circle where your y value equals a positive 1/2. And because there's two stopping points, that means there's 2 points of rotation that you have coterminal angles existing at. So just rotating around and around and around. All right, if you look at the next page, there's going to be a prettier chart filled in for you that shows everything together, okay? So when we're writing the general solution here, we have sine of x equals 1/2. So we said that because there are 2 points on the unit circle where y equals a positive 1/2, that's at pi over 6 and 5 pi over 6, I can rotate infinitely many times counterclockwise and clockwise, right? Which is how I'd represent this as plus 2 pi k, where k is an integer. This also applies for a cosine function. So if I have cosine of x equals 1/2, cosine is positive in two locations on the unit circle, in quadrant 1 and in quadrant 4, right? Quadrant 1, we're at pi over 3. Quadrant 4, we're at 5 pi over 3, correct? And they can rotate infinitely many times around counterclockwise and clockwise, okay? This works for certain points of tangent as well, but notice that for tangent, its full period is not 2 pi, its period is only 1 pi. Do you remember that? For tangent, the period is 1 pi. So instead of it being plus 2 pi, it is just plus pi, because that happens it only takes a period for tangent to start repeating. Yes? Are y'all with me? All right, so this is how you would write your general. And we're just using 1/2 and 1 just as friendlier numbers. Does that make sense? Easier to see, easier to recognize versus us using square root of 3 over 2 or something, right? Okay, so let's talk about it. Let's actually apply. So for example, here we have cosine of x equals negative square root of 2 over 2. So first off, we have a negative cosine. Cosine is negative in what quadrant? So what quadrants am I looking at? Remember, all students take calculus.
3 and 4. Oh.
2 and 3. So we're in quadrants 2 and quadrant 3. Cosine is only positive in 1 and in 4. Okay? All trig functions. Everybody's positive in quadrant 1. All. Okay? All sine and cosecant, tangent and cotangent, cosine and secant, which we'll learn about here in a little bit. Okay?
Is there a way to write cosecant and whatever the one is for cosine on the 2 angle form?
No, you just have to write them using their reciprocal identities. 1 over sine and 1 over cosine. Yeah. All right, so Q2 and Q3. So I'm looking for in quadrants 2 and quadrant 3, when do I have an x value, an x coordinate, I can spell coordinate, equal to negative square root of 2 over 2. That's what you're asking yourself. Remember, you will not have your unit circle on the AP test. So you need to be able to think, okay, I'm in quadrant 2, I'm in quadrant 3. At what angle values do I have this happen? Somebody, anybody. There we go. We should be at 3 pi over 4 and at x equals 5 pi over 4. Okay? It says find all solutions. So your all solutions have to include plus 2 pi k. Plus 2 pi k. Because it said all solutions. Does that make sense? All right. Questions, comments, concerns. Again, this would be on non-calculator. So you cannot check yourself. You can't refer to the calculator. This is a non-calculator question. Okay. Example 2. So example 2, it says find all solutions to the equation sine of x equals negative 1. Okay. Sine of x equals negative 1 lets you know that this has to be a quadrantal. Quadrantal angle. Remember, your quadrantal angles are your angles that make up your quadrants. So 0, 90, 180, 270, 360. These are our quadrantal angles because at any other point, do you get zeros and ones? No, you only get zeros and ones on your quadrantal angles. Make sense? So I'm looking for a quadrantal angle because it says negative 1 that will give sine a negative 1. So we're looking for the y coordinate to equal negative 1. Which quadrantal makes this true? It's going to be 270, which equals what in radians? So at 270 degrees, which equals what in radians?
Equals
3 pi over
2 radians.
3 pi over 2 radians. Okay, it said all solutions. So this is a singular solution. This would be if only if I was from 0 to 2 pi. Does that make sense? However, am I from 0 to 2 pi? No, it said all solutions. So my all solution would have to be 3 pi over 2 plus 2 pi times k.
So
It's meant to not like be like a hard problem. It's meant to be a knowledge check. Like, do you understand how the unit circle works? Do you understand what each piece represents?
you said the sine is the y over the hypotenuse. So the hypotenuse is always 1, even if the x doesn't change.
In this, when you're looking at a unit circle, your sine is just your y coordinate. Yeah. Unless you're drawing a triangle into the coordinate plane, your sine is just your y coordinate. Because it's a unit circle. And because it's a unit circle, your radius is automatically 1. Yes, sir.
Can you go back to example 1 for a second?
So in this current mode, I cannot. Yeah. Not being funny. I literally can't. It'll just be a blank screen. Yeah. All right. Any other questions? Comments? All right. Let's look at tangent example. So for tangent, we have tan x equals 1 over the square root of 3. Okay. So because of just using our knowledge of how tangent works, tangent is your y coordinate divided by your x coordinate. So we're looking for, first off, we need a positive tangent. So remember, all students take calculus, which means that we're only looking in quadrants 1 and 3, because you need positive tangent. And tangent is positive in quadrant 1 and in quadrant 3. Do we see that? So in quadrants 1 and 3, which angle will give me a tangent of 1 over square root of 3? It'll be what? So let's talk. You only have a couple options. Your options are either going to be pi over 6 or pi over 3, right? So it's pi over 6 or pi over 3. When you're thinking about their coordinates at pi over 6, the coordinate is square root of 3 over 2, comma, 1/2, correct? At pi over 3, its coordinates are 1/2 and square root of 3 over 2. Agree? When you're looking at tangent, this is your y divided by your x. So when I'm doing the math or thinking about it, this would be 1/2 times the reciprocal of this, which is 2 over the square root of 3, which equals 1 over the square root of 3. Do we see that? So it would be pi over 6, not pi over 3, because y divided by x, square root of 3 over 2, keep, change, flip, which would be 2 over 1, would just be square root of 3. And what did it want? 1 over the square root of 3. Do we see the difference?
Yes.
Yeah?
Does it say 3 or 7 on the next one?
3. Okay, so that's why it would be pi over 6. Yeah? So if it's pi over 6 in quadrant 1, what does it make it in quadrant 3? Yes. So what would be the angle in quadrant 3?
7 pi over 6.
7 pi over 6. You would be here at 7 pi over 6. So we were here at positive pi over 6, and we're here at positive 7 pi over 6. Make sense? So all of our solutions, so x equals pi over 6 plus
2 pi k.
How long does it take for tangent to repeat? 1 pi. So it's pi k.
That's interesting.
Because it's tangent. And we get the other one as? Also plus pi k. Remember, tangent is going to be just pi. It's only one period long. Yes.
The square root of 3 divided by 3 also be 1 over the square root of 3.
Yes, that's the rationalized answer.
So this is like irrational.
That was the irrational that they gave you. Okay? So whether it said square root of 3 over 3 or this, these are equivalent. Right? All right. How do we feel on non-calculator? Remember, that unit circle, I keep telling you, I cannot emphasize it as much. You need to know the unit circle, okay? If you know nothing else, you know quadrant 1, and you can do the rest, okay? Quadrant 1 is your friend. All right, so when we are solving trig functions, trig equations, there are 4 steps that we're going to follow. We isolate the trig function on one side of the equation. We find corresponding angle measurements using the unit circle, okay, that satisfies the given equation, and then consider any domain restriction. So if it comes down to trig inverse, we have to consider domain restrictions, and then write the solution and or general solution. So depending on if we're giving a domain restriction or not. Okay, so let's use this to navigate through here, okay? So the first thing we're going to do is isolate. So step 1 is to isolate your trig function. So that means that we need to get sine theta by itself. What do I need to do to get sine theta by itself? Divide by 6. What I do to one side, I'm going to do to the other. So we're left with sine theta equals square root of 2 over 2. Why is that? 6 and 3 are reducible, correct? 3 divided by 3 is 1. 6 divided by 3 is 2. So now we're down to sine theta equals square root of 2 over 2. Okay? Step 2 is to find the corresponding angle measurement on your unit circle that satisfies this. So I'm asking myself, what angle gives me a y coordinate, right? Because sine is your y coordinate of a positive square root of 2 over 2. We get it at theta equals 45 degrees, and where else? And it's going to be in quadrant number 2, sine, right? So what is the 45 in there? 135. Okay? So in radians, that puts us at pi over 4 and puts us at 3 pi over 4. Correct?
Yeah.
Okay? Because it says all, what do I need to include in my answers?
2 pi.
Yeah, that.
Oh, we could just do the same. Okay, I understand.
And we wrote our solution in our general form. So we considered our domain based on us being positive, which said we only can be in quadrants 1 and in quadrants 2. And then from there we identified. Yes.
Forgive me, but where are you getting these coordinates?
Our unit circle. The coordinates on the unit circle. That's where they are. Where we're getting them from.
That was still, how do you know which ones to get?
Look at your unit circle. The coordinates are on there. So you're asking, when does the y coordinate equal square root of 2 over 2? So you look around the unit circle. Where do I have the positive y value of square root of 2 over 2? If you don't have the unit circle memorized, then it's a good thing to have it out while you're doing this. But it's all from the unit circle.
Who doesn't know this?
I do.
You say you read the calculator. You say
All right. Let's try another one. So this time we have f of x equals 3 plus 2 cosine x and g of x equals 2. In the xy plane, what are the x coordinates of the points intersection of these two? So that means if I'm looking for points of intersection, I'm setting these two equal to each other. Does that make sense? The only way you're going to find a point of intersection is by setting them equal to each other. So we're setting f of x equal to g of x. F of x is 3 plus 2 cosine x. And g of x is just 2. So our steps are to isolate our trig. So we have to get cosine x by itself. What are the steps I'm going to take to get cosine x by itself? The first thing I'm going to do is subtract 3. Perfect. So now I've subtracted 3 and I'm left with 2 cosine x equals negative 1. Cosine x is still not by itself. So what's the next thing I need to do to get cosine x by itself? Divide by 2. So now cosine x is by itself. So I'm asking myself, cosine x equals negative 1/2. What are my restrictions for this? Which quadrants will cosine be negative in? In quadrant 2 and quadrant 3. So my angle has to be here or both in these two, right? So you're asking yourself, you're looking at the x coordinate, correct? Because cosine is your x coordinate. So what x coordinate in quadrant 2 or in quadrant 3 will give you negative 1/2? 7? It should be at your thirds. So cosine being 1/2, it has to be at your thirds, right? So your x being, remember, think of quadrant number 1. So in quadrant number 1, when I want to know the cosine of 60, it's just 1 on top, right? So that means 1/2. So in quadrant 1, I have a positive 1/2. So in quadrant 2, at all of my 60 marks, reference angles, I'm going to have a quadrant. I'm going to have a negative 1/2 or a positive 1/2. In this quadrant, you're looking right here. There we go. And we're looking right here, and we're looking right here. So this is, if this is 60, 180 minus 60 is 120. 180 plus 60 is 240. 360 minus 60 is 300. These two quadrants don't matter, right? Because we need a negative cosine. So it's 120 and 240. So the values of our x equal 120 degrees or 240 degrees. So I'm looking for all solutions that satisfy. So I can, or just on the interval from 0 to 2 pi. So either 120 degrees or in radians 2 pi over 3 and 4 pi over 3. It gave me a restriction. Okay? If you forget what the radians are, remember, just divide the degrees by what? 180. If you forget what your radians are, just divide your degrees by 180 and reduce. Does that make sense? So your first answer and your second answer. And as you can see again, this is requiring no calculator. Yes? Yes.
So what we have cos x equals 1/2. We find what degrees has that.
Yes, we're looking for the degree whose x coordinate is negative 1/2. Yes.
Okay, now I know.
There we go. All right. So summing it up, when we want square continue. When we want square trigonometric functions or raised to any exponent, we do not want our notation to be overly complicated or ambiguous. It wants to be pretty direct that this is what I'm looking for. Okay. We simply write x squared. So when we write it, you're not saying right here, we can write sine x to the n as sine square nx. So you don't have to use parentheses. The square with the power will just go on the trig. Does that make sense? Okay. If we want to square the whole trig equation, the power will just go on the trig. Does that make sense? So let's look at this. So when you read this, this says that we have g of x equals 3 minus 4 sine squared x. And it wants us to find the values of the zeros on the interval from 0 to 2 pi. Okay? Because it says of the zeros, that's telling us that we want to find g of x equal to 0. Does that make sense? So we're looking for when does g of x equal to 0. So g of x is 3 minus 4 squared x. So we're going to plug that in. So we have 3 minus 4 sine squared x equal to 0. Just like any other time you had x squared, you're going to solve this problem exactly the same. Does that make sense? No, sine squared, but I'm saying just as if this was x squared, we're going to solve the problem exactly the same. So the goal here is to get sine x by itself. Ultimately, we need sine x by itself. If it bothers you to see it written like this and it helps you with your steps, it can also be written as 3 minus 4 parentheses sine x squared equals 0. So if it bothers you to see the power on the sign instead of over the entire function, you can rewrite it where it's written in parentheses. And sometimes it helps people remember, I have to take the square root. Okay, so let's begin. What are my steps to get to sine x? I'm going to subtract 3. Okay, so now after I subtract 3, what am I going to do? Divide by negative 4. After I divide by negative 4, what's going to be left for me to do? I'm going to take the square root. And what I do to one side, I'm going to do to the other side. Can someone let Mr. Huff in? So this gives me the square root of a negative divided by a negative is a positive. So we get the square root of 3/4. When you take the square root of a fraction, you're taking the square root of the numerator and the denominator, okay? Also, when you take the square root of something, it produces a positive and a negative. So when I take the square root, I end up with plus or minus the square root of 3 over 2. Okay, when you take the square root, you're taking the square root of the numerator and the denominator, and you're going to end up with a positive and a negative solution. What is the square root of 3? It's just going to be square root of 3. What is the square root of 4? 2. And I'm going to have a positive and a negative of the solution. Are we good? So what makes this beautiful is that all you're doing at this point is you're going to have to list out every value on your unit circle, right? Because you want the positive and the negative values that make sine x equal to this.
Sine x?
Mm-hmm.
No, sine.
Because it's sine x. So on our unit circle, we're just looking for all y coordinates that equal either a positive square root of 3 over 2 or a negative square root of 3 over 2. So we're looking for all of the y coordinates that make this true. Huh? So that would be all of our thirds, our 60s. So our answer would be x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Because it gave us our interval. Okay, so do you see what happens when you take the square root while solving a trig equation? Okay, you have to take into account the positive and the negative, which just means at this point, it doesn't matter what quadrant you're in. It's going to be all of them. Yes? Doable?
Doable.
All right. How many of y'all remember how to factor? Do we remember how to factor? Yeah. GCF? Yeah? No? Okay. What we're going to do is we're going to, when you have a trig function on both sides, I'm going to model for you what's called U substitution. Okay. What we're going to do is just let U represent the trig function, and we're just going to write it as a basic algebra problem. Okay. So for this problem, we have a trig function on both sides. We have cosine theta. Cosine theta, correct? So we're going to let U equal cosine theta. What that means is everywhere that cosine theta is, we're going to substitute it in with the U. So this is going to become U squared equals negative U. Because we're letting U be what? Cosine. Okay? When you get to AP calculus, you're going to do a lot more intense U substitution. This is just baby U substitution. Okay? So now I just got to solve this. So to solve this, we got to make one side equal to 0, because that's how you solve quadratics. One side has to be equal to 0. Then you factor and set each factor equal to 0. Yes, Hudson.
On one of these it says
Hudson, not right now. I'm in the middle of teaching a lesson. U squared plus U equals 0. So this goes back to, Algebra 1 101. In order to solve this, we factor and set each factor equal to 0. Factor here is GCF, greatest common factor. The greatest common factor is U. So we're going to factor out our GCF, and we're left with U times U plus 1. To solve this, that means you're taking each one of your U's and setting it equal to 0. So we have U equals 0, and we have U plus 1 equals 0. Are we really solving U, though? It's cost. So now that you're down to this, you can now plug cosine back in. So you're asking yourself, when does cosine theta equal 0? When does cosine theta plus 1 equal 0? This becomes cosine theta equals -1. So on your unit circle, when does cosine theta equal 0? And when does cosine theta equal -1? That's what you're asking yourself. So our thetas would be what?
Or theta.
What thing? 0 and pi.
Oh wait, I understand now.
So I need a -1 and I need a cosine theta equal to 0. When does that happen?
I think it's at pi.
Whenever it's like 3 pi.
When is your x coordinate 0?
Whenever it's at the half.
At pi over 2.
At 90 and 270.
270.
So your first answer here, this is asking when is your x coordinate 0? This is asking when is your x coordinate -1. So our answers are theta equals pi over 2, correct? 3 pi over 2, because that's when your x coordinates are 0. And then when is your x coordinate -1?
Pi.
At pi. Okay, so the purpose of u substitution is to make this down to something that you realize you know how to do, right? You know how to factor out GCF. You know how to factor. You know how to set factors equal to 0. A lot of times we get overwhelmed with seeing trig values in the place of a variable, right? An unknown trig value is a variable. It's just a variable with a lot of extra around it, right? But it's still the same thing, okay? So if you are comfortable, you could leave it as cosine squared plus cosine equals 0. Factor out the cosine, set each one equal. U substitution is just like a little friendly trick for our brain to see that we already know how to do this.
I thought looking for -1 equals cos, not the
It
sine.
might sound like a.
We are x coordinate,
Oh.
so you're looking for at the x coordinate, and at the x coordinate on pi, we have -1. The sign is 0. The y coordinate is 0. Okay?
Oh.
All right, our last and final example on part 1. This took a little longer than I anticipated, but that's okay. We're learning. All right, so on here we have f of x equals 2 sine squared x, and g of x equals the square root of 3 sine x. In the xy plane, what are the x coordinates of the points of intersection? Okay, if I'm asking for the x coordinates of the points of intersection, what does that tell you we're doing? We're doing what with f of x and g of x? We're going to set them equal to each other. Okay? If you're looking for the intersection, that means you're taking f and setting it equal to g. So we have 2 sine squared x equals the square root of 3 sine x. Okay? Remember, if it's overwhelming for you to see trig on both sides, what can you do? You can use u substitution, right? So if it's too much, like, ooh, that's a lot happening there, you can rewrite it as u substitution. So for u substitution, this becomes 2u squared equals square root of 3u. And u is just what for us right now? Sine x. So we're going to solve this as normal until we get down to what we need. Okay? The difference here is that when you're solving this one, it may not, there's a couple things you have to remember. You can solve everything the same. If you want to use quadratic formula, there's no reason because you don't have a third term. But remember, just use GCF. especially in something this simple, okay? So we're going to square root of 3u from both sides.
Wait, minus or divide?
You're minusing. You do not divide. Do not divide the values.
But
If I divide, will this side equal 0?
but they're oh, I thought you were just taking out the square root.
We need this side to be equal to 0. Or you cannot do the 0 factor
Yeah, I
property.
thought you were taking out just the square root of 3.
Yep. So we have 2u squared minus 3 cube root of square root of 3 u equals 0. Okay, so the difference here is, again, you're just taking out the GCF, and our GCF is u. So now we're left with u times 2u minus the square root of 3 equals 0. Once you have your factors, you can substitute back in and just solve. So we are left with u as a factor, so that means sine x equals 0 is the first one we're asking ourselves. And then the next one, 2 sine x minus square root of 3 equals 0. This was the easy one. You're asking yourself, when on your unit circle does the y coordinate equal 0? 180 and 0. Does that make sense? So we know that for this one, your x equals 0 and pi. Or 0 and 180, but it asks for intervals from 0 to 2 pi. That's the easy one. Exactly. Okay? Questions about the easy one?
How do you get from the top red equation?
Uh-huh.
That one, how do you get that to sin x equals 0?
So u, we resubstitute it. So what does u represent?
Equals sin x.
So sine x equal 0 and 2u.
Oh, okay, I understand.
Remember, once you have your factors, you can now put your u back in for the problem and you solve.
Okay. Yeah.
Okay? On this one, we are going to add the square root of 3 and divide by 2. Make sense? So you're asking yourself on your unit circle, what y coordinates do you end up with a positive square root of 3 over 2? So what y coordinates give you a positive square root of 3 over 2? So you're in quadrant, what quadrants? 1 and 2. And you're going to get pi over 3 and 2 pi over 3. So at x equals pi over 3 and at 2 pi over 3. So your 4 solutions are as follows. Now what this means is if you were to graph these two and find their intersections on the interval from 0 to 2 pi, you would see that they are intersecting at these points. The thing is, on a handheld calculator, it's going to give you an approximate value, right? It's not going to tell you pi. It's not going to tell you pi over 3, 2 pi over 3, okay? That's because, one, you wouldn't use a calculator on this. It's meant to be used with the unit circle, okay?